Hi guys, so I'm going to start with a model today. There are 7 layers inside OSI model. The first one is application layer, which also called as layer 7, means L7. Why I'm segregating this like this, I will tell you in the end. Number 2 is presentation layer. It is known as L6. Number 3 will be session layer. It is known as L5. These 3 layers are called as upper layers. Okay. This is used by software designers, as Praphul Bhai told. Our main work as a network engineer, our main work is to work on these lower layers, these last 4 layers, which is 4. Export layer. It is called as level 4. 5. Network layer. It's called as layer 3. Then data link layer. It's called as layer 2. Inside this data link layer, there are 2 sub layers. Number 1 is MAC. Number 2 is LLC, logical link control. And number 7 is physical layer. It's called as L1. So I will defining one thing from the physical layer, layer 1. What are the layer 1? Layer 1 means the physical media, means the cables, fiber cables or the Ethernet cables, which are connecting devices and from where the data will be transmitted from here to there. Layer 2, data link layer. Data link layer is nothing but switch. You can tell switch as a data link layer, which work is to they are having data link layer is a very big thing. In this layer, the segments are converted into frames, and it's switched based on the MAC addresses, source and destination MAC addresses. MAC addresses. What is the MAC address? Where MAC address is a unique address of a device, which you can. Which cannot be same at the 2 devices. Okay, and MAC address, it consists of 48 bits, and first 20 bits are deserved as OUI, means organization unique identifier. What is organization unique identifier? Organization unique identifiers are like, let's suppose we are using Cisco routers. Okay, so in all Cisco routers, first 24 bits will be same for all Cisco devices, which is Cisco organization's unique identifier. From that MAC address, we can identify that this device is a Cisco device. And next 24 bits will be the actual MAC address based on which the traffics will be moving forward. And LLC in the sense nothing but logical link control. Some of the protocols are used in switching technology like STP, VTP, DTP. Those data plane traffics, those control plane traffics will be handled by this LLC, means logical link control sublayer. Okay, so what does it mean? Means in switch there are in data link layer, one is for forwarding plane, means to forward the actual data, which is MAC, and LLC is for the control plane traffic, which will be not shared to throughout the users, which is used to only switches and routers to take the decisions for path manipulation, for STP, for other protocols. Okay.
Can you please repeat the part of the MAC and the LLC?
Okay, definitely. MAC is for forwarding traffic and LLC is for control plane traffic. What is the difference between control plane and forwarding plane? Do you know?
No.
Okay, let me explain. So while studying CCNA, you have studied about some protocols like routing protocols, switching protocols.
Yes.
Based on the protocols, switches and routers making their decisions. Like from routing protocols, we use routers updating their routing tables, and from that routing table, the data are going to be forwarded, right?
Yes.
But is this informations are come to our desktop screen or our computer screen? Like I am sending one hi to you. Hi, what is your name?
Haruna.
Haruna. Hi, Haruna. The hi, Haruna will be sent to you.
Okay.
But how it is going to be sent, from which way it is going to be sent, these things will be taking the decision by, these decisions will be taken care by the control plane unit. Control plane unit, nothing but the data which it's shared within the network, within the devices to make the understandings and make the decisions from which path the data will go, and the traffic which you are receiving, which I am sending, that is called forwarding plane traffic. So this is the difference between forwarding plane and control plane. Forwarding plane is to the main data which we are going to share. Anything, it can be HTTP traffic, HTTPS traffic, telnet traffic, that is forwarding plane. And data plane or control plane traffic is to for the protocols from where routers and switches are getting the decisions. Okay. So logical link control is for control plane traffic to manage the protocols and take decisions, and MAC is for forwarding plane traffic to switch the packets from one source to another destination.
Okay.
Got it?
Yes.
Now coming to network layer. Network layer are nothing but IP addresses and actually routers. Routers are actually network layers. Layer 3 means how to create the routing table from source to destination, how the address will be traversed from the source towards the destination. Routers are network layer. Transport layer means the mode of communication, how the traffic will flow, in which metric the traffic will flow. TCP and UDP, these two types of protocols are there. Right, as Praphul just now told you, TCP and UDP, the source port, destination port, everything, it will add those headers to make decisions how the packet will be transmitted from one source to another destination. Okay, session layer is nothing but it's a very small how your device connectivity is. The session, this is the session we are attending, right? So if our Ethernet cable is not working well, or I don't have the internet connectivity, so the session will be not created, right? So this is called as a session layer. Presentation layer, what will presentation layer do? Presentation layer represents the data. It segregates the data. Means when we are sending some data from one source towards a destination, it can be a text message, it can be a video, it can be a voice. How it will be get segregated? It will be segregated by presentation layer. Presentation layer will decide which data will go to for which destination. Okay, and the application layer, nothing but is the application through which you are going to transmit the packets. Means everything up to this layer, everything is perfect for you. Like you have the physical cable connectivity is very well. You have connected the switch towards your network. You have connected the routers or firewalls in your network. You are working the routing protocols very good. Okay, you have the session ID. Okay, presentation layer also working fine, but you don't have the application of Facebook. Facebook application or Messenger application you don't have installed in your device. Can you communicate with me through the Messenger?
No, not possible.
Right. So in that purpose, we need application layer. Application layer is nothing but is the application which process the data. From that platform, we can communicate with each another. This is the brief about OSI model. So coming to first physical layer. Physical layer having two types of cables. One is copper cables, another one is fiber cables. Copper cables are like Ethernet media, which distance range is only about 100 meters. Okay, if we can need to extend the copper cables more than 100 meters, then we have to connect repeater in between the distance. Every 100 meter we have to connect, not actually 100 meter. If we are using complete 100 meter, then the communication also will be having very much gap. So within the 80 meters we have to connect a repeater to extend the connectivity. To resolve this problem, engineers have came to one other concept that is called fiber connectivity, and instead of electrical bits, they are converting the electrical bits into the laser ray and converting and moves the traffic inside the fiber cable. So fiber cable is nothing but inside the copper Ethernet media cable, copper cable, you will find the 4 pair of cables like white orange, white green, white blue, then white green. After that, brown pairs, means white, brown, and brown.
Yes, Dev, there you can show them in Google as well, right? You can find the images easily.
Yes.
That will be more attractive, right?
Okay,
Anyone can easily get it.
Okay. So
Just type in Ethernet cable pin, like, yeah, click on images, click on images. No, click on images. Yes.
see, this is the pairs I have discussed you.
Yeah.
So see, these are the pairs: orange pair, green pair, blue pair, and gray pair, brown pair. The main work within this pair, the main works are done by orange and green pair. Those are RX and TX. Orange means receiving section, RX, and green means transmit section, means TX. So do you understand what is RX and TX? Anybody can answer what is RX and TX?
Yeah, transmission and reception.
Yes, whenever you are connecting a cable from a switch towards your Ethernet adapter, you can see one side one green light is blinking and one side one orange light is blinking. Means transmit and receiving is fine in the desktop. Orange means transmit, green means receive. Sorry, orange means receive, green means transmit. So how the pairs, there are two types of cables. One is straight cable and one is cross cable. So cross cable concept is not now, this is very old concept, but still make in mind that same kind of devices can be connected through cross cable and different kind of layout devices can be connected by straight cable. Straight cables connects like if you are connecting one router to another router, you need a cross cable.
Same group devices.
You will need a switch to switch connectivity, but nowadays we all are working with straight cables. Cross cables concept is gone.
Yeah.
Okay.
Yeah, so there's only one type of for the new devices, right? It's or for the new cables.
Yes. And the pair will be starting from, I'm telling, and the brown pair. Why do anybody can answer that? What is the purpose of using this brown pair?
What you can do, boss, you can copy this image and you can paste it in Paint, right? That will be visible for everyone, I think. Yeah, okay. Just copy it, click there and copy image. Okay, let's open your Paint and paste
but
it. But
Prabhu sir, if I get the pen and tab, then it will be very good for understanding.
Definitely,
the
you will get it tomorrow or maybe after tomorrow. I have already
Okay.
ordered to your location.
Hmm.
Yeah, now it's
Okay,
visible.
everybody can see.
Yeah.
Hmm. So the orange pair is a RX pair, means receiving pair, and the green pair is TX, means transmit. Each and every device need to have these two units. One RX, one is TX. From one it will receive and from one it will transmit. Okay. Can anyone tell what is the purpose of using this gray pair? It is a very much asked question. It's a very basic question in interview level.
It,
Can you tell me what
it
is the
might
purpose
be
of
for brown cable, na?
brown? Yes, brown.
It might be for electricity,
Yes, you are very near about this. You are very near about this.
electric signal.
Yes, definitely not electric signals. Nowadays, what we are doing, like if we are trying to connect a CCTV camera, okay, from a switch port,
Okay.
what did previously how we were doing? We are connecting the camera first. We are giving
PoE, power over Ethernet.
yes for PPP, power over the Ethernet.
PoE.
This pair transmits the power to the device, so that we need to no need to use any adapters and no need to use any electrical port and all. That resolves this problem by this pair. This pair throws the power through the switch port.
The brown one, right?
The brown one.
Hmm.
It just this pair will be receiving purpose. The green pair will be for transmit purpose, and this pair will be for the power transmission purpose. So what, we don't need any charger or we don't need any power adapter to make the device powered on. Through the Ethernet cable itself, the device can be get powered on. And nowadays, the modules are the switch modules and the switch slots are converted to PPP,
PoE.
means power over the Ethernet modules, so that modules can throw the power itself. No need the power adapters. Mostly these cables are used for CCTV camera connectivities. For CCTV camera, we have to put the CCTV camera over that tree somewhere over, but in that places we cannot. It's not possible to make a electrical point or like that. That's why this comes to in the picture. Anybody can tell what is the purpose of using this blue pair?
I was about to ask.
Anybody can?
This is also an interview question. I have received this question in interview.
Okay, let me explain. Blue pair is nothing but this is a redundancy pair, or you can say as a alternative pair. If any of this pair are getting damaged, means blue pair or orange pair, receiving or transmit pair. So in that purpose, we can use this blue pair as RX as TX itself. Just assume I have one connectivity, and inside that connectivity, that blue pair, this orange pair got damaged. That time I can use this blue pair as a receiving section, white, orange, and white, blue, and blue. In the same way, vice versa, if inside a cable, if this green pair also goes down or it's stopped working, so that we can use this redundant blue pair as a TX. So you can use this for this is a variable pair. Okay, you can use it for transmit as well as receiving instead of this orange and green pairs.
So its role, the role of the blue pair is just there for redundancy.
Yes, blue pair is for the redundancy. It's like a reserve pair. We don't use it. There is nothing used in this. But if any pair goes down from RX and TX, we can use this blue pair as RX as well as TX. Whatever we need, as per our need, we can use it.
Okay, so the orange one is for transmission.
Yes, not transmission, only receive, RX.
RX, okay.
And green one is TX, transmit.
And the green one is for transmission.
Yes, transmission, TX.
Okay, the blue one is only for
it can be used for RX and TX both if one of the pair got damaged.
Goes down for redundancy in case.
And brown one is for throwing the power through
transmission.
Through PoE, power over the Ethernet.
Mm-hmm.
So am I clear to all of you?
Yes.
So the next part is when we are using repeaters and all, it is very, and here the work is very tough because we need to put receiver in between every 80 meters and all to extend the connection. So to resolve this problem, engineers have came with a new technology, which is fiber technology. For fiber technology, there is no limitation. We can send the data from here to the moon. Wow. Without any repetition or like that. Okay, because there is in these cables, within these pairs or these cables, copper cables, what actually that we transmits, the data transmits as electrical bits, right? But whenever the fiber concept comes to the picture, they are using another transmitter to transmit this electrical bit into laser bit. Laser bit means laser ray. Inside the fiber, if you anybody seen that fiber, I'm showing you the fiber picture. After that, I will explain.
So hope everyone is enjoying. Yes or no?
See. This is fiber cables.
Salman, are you getting? Salman, am I audible?
Yes.
Yes?
Yes.
So hope everyone is getting, right? Everyone is enjoying.
Images.
Yes, Pathela?
Yes, sir.
Okay.
Yes, sir.
Yes, this image I want. This image I want. This is the image. See, this is how fiber core looks like. There are two types of things inside the fiber. One is core, one is cladding. Okay, core is the main thing from where the data will be transmitted. Means electrical bits will be converted to ray signals, and it will be put into this core part, and it will be moved. And this is very sensitive, and that's why we need so many precautions, because if fiber cut happens, so connectivity will be lost from one city to another city, right? Do you know about submarine cabling, how the things are connected? Anybody aware about that submarine cabling? No, right?
Oh my God.
Hello?
Yes, no.
Okay, submarine cabling is nothing but before we are connecting YouTube, we are connecting Facebook, but these things are also a server or multiple servers, which we need the connectivity from our end to that server. So that we are making connectivity through cables, and long distance connectivities are not done by the Ethernet cables nowadays. Okay, those are connected by fiber media only. And the fiber media, which is connecting from one country to another country, those are laid under the water, under the seas, from the seas. Like from India's first hub is Singapore. From Singapore, the traffic will be moved towards the USA or the servers in Alaska, wherever it is located. Okay, so this from India to the Singapore, there should be one gateway which will be connected. So the cables are laid under the waters, the fiber cables, and connecting these two countries. These are the submarine cabling.
Under the water.
Under the water, the submarine. That's why it's called submarine cabling.
I've never heard of that. Okay.
So submarine cabling, fiber things are done by submarine, means fiber technology is used in submarine cabling, and they are having so many protections. First thing is core, from where the laser bit will be passed. After that, one cladding will be there. After that, some PVC jacket will be there. After PVC jacket, there will be some metal jacket. After the metal jacket, again it will be a PVC jacket, and it covered because it is very sensitive. If you ever have seen the core or cladding, no, it is like your hair thin. It's that much of thin. Okay, and it can be break. It is very sensitive. It is very, who are using these fiber cables, no, they are using it very carefully because its costs also very high. Okay, if you can see the cost of one patch cord, it's like 930 in Indian rupees, 977 in Indian rupees. Okay, there are some types of connectors also there. Okay, that I will come on it. So this is the actual means physical layer works, and I will discuss the fiber technology. Fiber technology is having two types of cables. One is single mode, another one is multi-mode. Okay. What is single mode and what is the difference between single mode and multi-mode is that single mode core area is around 0.25 to 0.75 micron, and the cladding area will be 100 to 125 micron. And multi-mode cables are like inside core will be 100 to 125 micron, and the cladding will be 125 to 150 micron. We have lots of insertion losses inside the single mode cable, but in multi-mode cable insertion loss is very less. Why? Because because if you see this image, I'm copying this image. What does you mean by insertion loss? See, the core area from where the data will be moved, right? This is very thin. This is very small. In the hole is very small in fiber cable. So if you take a torch, okay, you just take a torch and try to put something inside one hole, small or big hole. Okay, so minimum, if the hole is very small, minimum light will be passed inside the hole, and the maximum light will be not passed. It will be go outside, right? And if the hole is bigger, then maximum light will be go inside and minimum light will be lost. That's called insertion loss. So we are having much insertion loss in single mode cable, but in multi-mode cable we don't have that much insertion loss. Did you guys understood what is insertion loss?
Not really.
Dev Jyoti sir.
Yes.
That means the transmission of signal, when we transmit the signal, some of intensity, but we cannot receive the signal at the same intensity. The sum of the signal will be distracted and some of the signal will be lost. Some of the light.
Yes, in fiber loss is there because you understood the things, right?
I'm just
like in paint. I am taking one more page. That's why I need the pen and paper. I need to draw the diagrams.
Like a flow of water. If we have a small hole of water, okay, and our flow of water is higher.
Exactly. You got my point. That will be the next point. We are using single mode cables to connect distance devices. And closer devices we are using single multi-mode cable. Multi-mode cable is having the hole is very less, so the pressure will be not there inside it. But if the hole is small, the pressure will be much. Because did you ever use the pipe? Using pipe, you are giving water to the trees. We are having multiple pipes, right, to give water to the trees, right? If we make the hole small, then the water floods much far away. But if the hole is like same, the water will not move that much far away. That is the concept using here in single mode and multi-mode. In single mode, insertion loss will be there. In multi-mode, insertion loss will be less. But in single mode, it will connect much more distance devices than multi-mode cables. Did you understand this point?
Yes, got it.
Let's see. This is a device. Okay. This is another device. This is located in. I'm not drawing that subnet and all. Just assume this as a router. Okay. Don't say. This is a router. This is a router. This is located in US, India. This is located in Singapore. Let's suppose. Okay. So, how the cables will be connected? From here to there, we will have a fiber connection. True?
Yes.
Fiber connect. You can see the SFP ports. Anybody seen the SFP ports in the switch? SFP modules. We need to have some SFP, which is seen like a.
Where we insert the SFP like ER, ZR.
Yes, we have to insert the SFP. From the SFP, you have to connect the fiber cables. Without SFP, you cannot.
Yes.
Yes. For fibers, we are using SFPs, fiber SFP. Ethernet SFPs are also there to increase the bandwidth of the port. But fiber, must we have to use SFP. Okay. So how it will be connected? This router is connected throughout a fiber cable. After that, when let's say this is your home and you have a switch here. You have a switch here in your home. Then how it will connect? Your switch doesn't have any any SFP. You have a D-Link normal switch. You don't have a SFP port inside that kind of switches. So we will use a media converter in between this. Okay. The connection, from the ISP connection, the fiber connection will be terminated here inside. Will be terminated here inside the media converter. And in media converter, there will be two ports. One will be fiber port and one will be copper port. Copper port means Ethernet port. Okay. Media converter, what it does? It converts the data from electrical bit to fiber ray and fiber ray to electrical bit. Okay. Whenever we are receiving some data in the laser ray format, it will be reached inside the media converter first. The media converter will convert the data to electrical bits, and one port, Ethernet port, will be there from here to your switch, which will connect your switch, and this data will be come to your switch and you will get the response. Understood? Understood the things?
Yeah.
Yes, sir.
It means the laser ray will be travels from here to here. After coming here, it will check its destination. Let's suppose it find this as a destination port. It will come to this interface and will move this traffic towards the media converter, towards your home. When it reaches your home, before moving this signal towards your switch, it will reach out to this media converter. Media converter will convert the electrical ray, the fiber ray into the electrical bits, and it will transfers it to your switch and you will get the reply. Vice versa, whenever you are trying to send any request, it's for reply. But when you are surfing something, you need to download or you need to ask something in when this is the destination and this is the destination and this is the source. That scenario I have told. We have the vice versa scenario also. When we are requesting something towards the internet, that time how it will go? The same, like here it will generate the electrical bits. From the electrical bits will be travels through this port to this media converter Ethernet port, And from this media converter Ethernet port, again the electrical bits will be changed into laser ray and will travels through this. Likewise, this vice versa communication will be established. So, how many of you understood this?
Yes, understood, sir.
Yeah,
These are the very basic things, okay, which I was not supposed to be cleared. I am already hired for the advanced things, but for your understanding, I am just doing this. Understood this one. So physical layer gone. Physical layer. Now I will say data link layer. What is data link layer? Already I told you. There is two types of things, MAC and LLC. MAC is for forwarding plane traffic and LLC is to control the control plane traffic. From LLC, it handles the protocols like STP, VTP, DTP, what types of protocols are used in switching technology. It's controlled by LLC, logical link control sub layer. And MAC layer is to just switch the traffic from one source to another destination. Their switches are creating MAC tables, generating ARP. I will be come to these things later. Do you know about ARP, address resolution protocol?
Yes.
What is ARP? How switch will ARP generate the ARP?
Well, are you asking for the purpose of ARP?
Yes. What is the purpose of ARP?
ARP is when you have knowledge of the IP address and you use it to ask for the MAC address.
Switch. ARP means it broadcasts something. Broadcast something means you
it broadcasts the signal. ARP means it broadcast. If suppose my source port, I know the source IP and destination IP, but I didn't know the destination MAC address. Then ARP will generate it.
First, tell how a device from a source towards the destination, how the communication happens. I will show you that now. Always keep in mind, and inside this, one thing I forgot about this, there are two types of data link layer, means two types of media used in. One is switch and another one is was hub.
Switch and what?
Hub works at layer 1, boss.
Layer 1, that's right. I am going to tell the difference between switch and hub. Okay.
The hub, yeah.
What is the difference between switches and hubs? Switches are newly designed technology and hubs are old technology. Hubs transmission is very less slow, switches transmission is very fast, because the main thing, each switch ports are in the one collision domain. Means, do you know what is collision domain?
Yes.
Sir, Praphul sir, just please arrange the pen and paper, otherwise it is...
Definitely, this is on the way. After tomorrow, definitely you will be teaching through pen tab.
Yes, that's it. It will be very helpful for the students. And
extremely sorry for delay.
These things can be explainable more details if I have the pen and tab.
Definitely. So, who is going to explain collision domain?
Yeah, the collision. I'll try.
Okay.
A collision domain is an Ethernet scenario where one device send a signal and all the other devices are forced to listen to that device.
First of all, let us know what is collision domain. Domain means area and collision means colliding something. That means collision domain means we are talking about some area where collision can be occur, right?
Yes.
Collision domain is nothing but I'm just giving one example to you. Like let's suppose this is a switch, okay, and this is a hub. Hubs, all ports are in same collision domain, but switches, all ports are in different collision domain. What is collision domain? Means inside the hub, if you see, inside hub, here will be the ports, right? Here will be the ports. But the ports will be in the same collision domain, okay? And in switch, the collision domain will be different for each port. So what it happens, when any data sends or received by the hub, what it will do, hub was actually software defined, the transmission and receive this was software defined. And in the internet, the first thing is the first formula of transmission and receive is first come and first serve. Which traffic will receive first, it will be transmitted first, then second one, then third one, likewise. Okay, line by line, first come first serve technology is done in this networking technology. Okay, so hub was actually software managed transmission and receiver, but switch is hardware managed, soft means the transmit and receiving. Okay, and switch, each port will be on different collision domain. What happens here, we don't have the separation of collision domain over here at the hub. So if any data traffic enters here, the collision, and the same time, let's suppose one data traffic came for this destination port, and in the same time this port is transmitting one data. So collision might be happen because the partitions was not there inside this hub technology. This is under the same collision domain, but in switch it is not possible because these ports transmission and receiving will be done from one collision. This other ports transmission and receive will be in other collision domain. So collision will be not possible in switching technology, but in hub collision will be there. And for hub, the technology will be in this. It cannot send the data from all the ports simultaneously. Okay, it have to wait. First, this port receive the data. Until that time, this port will be on hold, and all the things will be managed by the software. Okay, first this data will be received through this port. Once it is done, after that this can be transmit. So the process was very late. So engineers came into their mind and they have introduced switch with the different collision domains. And in different collision domain, we don't need to wait for any other traffic. In the same time, if this port can receive data and this port can transmit data, this port can receive data, this port can transmit data. We don't need to wait for this. But in hub, we have to wait for this. One by one, it's happening because collision domain was not partitioned here, and collision domain is partitioned in switch. Understand the technology?
Yes.
If you have any doubt, please question me.
Yeah, I think it's just that I did not know how to I did not know exactly how to explain myself. But what I meant by a collision domain is, like I said, it's an alternate scenario where one device will send and all of the other devices are forcing to listen, and if one other device send at the same time, there will be a collision, like in the same area. That's
yes,
what I meant.
Same thing I explained.
Yeah, that's probably why the CSMA CD was put in place to avoid those type of collisions. Yeah.
This is a symbol of hub and this is a symbol of switch.
The switch.
Switch symbol is this. This is a symbol of switch. Why? Because
1 and 2. Okay, back in.
It can be transmit so many data from at a time simultaneously, and hub is this. It have to be wait. One data will be transmitted. After that, until that time, the next data will be wait until one data is, and who will come first, it will be getting served by first. Understood this thing?
Yes, very much.
Okay, so MAC, already I told what is MAC. MAC is nothing but it's a unique code of a device to, it's each and every device. Like if you see here in my PC. What will be my MAC address? I will go here, network to status details. This is my MAC address.
Physical address up there. Physical address on the top.
On the top. Yeah.
This is sorry. This is my MAC address, and this consists actually 48 bits. As I told you, this first 24 bits will be reserved for OUI, means Organization Unique Identifier, which will from where we can identify the vendor. This network driver belongs to which vendor. It will be knowing by this Organization Unique Identifier, and this last 3 bits will define it will be changed, and from this we will get to know which device means unique devices, and basing on these things, switches are switching the data frames. Okay. Next was an LLC. Already I told, for control plane traffic, for STP, those things. Network layer.
Next topic can be Ethernet header.
Yes.
So that we can finish layer 2, right? Data link layer.
Yes.
Then we will move to network layer. That will be good, I think.
Yes. Let me first.
Just go to Google and search Ethernet header. Directly you can explain there.
Ethernet header I can explain there. Ethernet headers, they are having Ethernet header, right? What are the Ethernet headers? What are the properties of Ethernet header? So first one is preamble. Destination MAC. Source MAC. Then it comes type field. Then it comes the actual data which you are sending or receiving. Then it's FCS. After FCS, the IP header starts. So, what is preamble? Do you know anybody about preamble? Hello?
No, sir.
Okay.
Yes. Hello.
Preamble is nothing but consist 8 bits. Okay. And it is differentiating one data from other data. Means when we are forwarding some data towards a destination, it will be received through our desktop. Okay. But how it will identify that this is for this packets are separate? Preamble will separate the packets. Preamble will be 7-bit, and inside the preamble 1 bit will be there. That is SFD. What is SFD works? SFD works for from where the data information will be started. That is explained by that for to know those things. SFD works, right? So what is preamble? Preamble is all data are separated by preamble, and SFD means start frame delimiter, means from where the information will be getting started. The data information will be getting started, which will be explained by SFD. Okay. After that, source MAC. Source MAC means the thing what I am going to explain you. Source MAC and destination MAC. How the
sorry.
Tell me.
So what we have was is it the IP header? Was it
after this we can go for the IP header?
So the destination, the source, what we have. So what header is that? What was that? The
source MAC and destination MAC. That's what I am going to teach you. Okay.
Okay.
Let's suppose this is a device. Remind one thing: switches, all ports are in different collision domain and in same broadcast domain, and routers, each ports belongs to one broadcast domain. Each port, each broadcast domain, but switches are in a same broadcast domain.
Yes.
Keep this thing in mind always. So how router, let's suppose this is TENS network 10.0.1/24 /30. This is the point-to-point connection. Here we having a LAN subnet, which is 10.0.1.0/24. Here 10.0.2.0/24. These are the LAN subnets, and this is the point-to-point link. And here this is a device. Let's suppose this IP address is 10.0.1.2. Gateway address will be 1.1. In this interface, here in this interface, this one 10.0.2.2. This one is 10.0.2.3, and gateway will be, for this one, gateway will be 10.0.1.1. Same here. In this interface, we'll have 10.0.2.1/24. Gateway 10.0.2.1/24. So here define this device is MAC as MAC A. This is MAC B. This interface having MAC C. This interface having MAC B. This interface having MAC E. This interface having MAC F. In these two pieces, MAC H, MAC I. Okay, so now let's suppose one user from 10.1.1.2 wants to send some data to 10.0.2.2. How the packets will be moved from here, that I will explain you. First, in the IP header, I will explain the IP header later. Just listen to this carefully, how the packet travels. After that, I will definitely show you the properties and all, the practical, the theoretical part. But first, understand this practical part. Okay. So first, when 10.1.2, 10.0.1.2 needs to be communicate with 10.0.2.1, what it will do is, inside it will first move towards its gateway. Gateway means 10.0.0.1. From that gateway, it will search the 10.0.2. network inside its routing table. It will find the routing table. It can be forwarded through this interface, this MACD interface, and after that it will reach here, and from here it will see this 10.0.2.0. the interface is directly connected with this interface, and it will move the data here, and likewise the packets will be traveled. So what technology, how it travels, that I am showing you. Always remember in mind, let's suppose this is a box. So in this IP header, let's say these are source IP, and this is destination IP. Source IP will be 10.0.1.2 and destination IP will be 10.0.2.2. These things will not be changed. What things will be changed? The source MAC and destination MAC. First, when it will try to send one traffic towards this 10.0.2.2 network, that time the source MAC will be MAC B, okay, and the destination MAC will be MAC C. Once it is reaching to this interface, it will see that this 10.0.2.0 network is connected, is some other router in this routing table, and the forwarding port is this port. So that time it will change its source and destination MAC. That time the source MAC will be MAC C, and destination MAC will be MAC D. Once it's reached towards this interface, after that it needs to be traversed to this interface, right? That time it will change the source MAC as MAC D and destination MAC will be MAC E. When it reaches, the packet reaches towards this router, after that it will see it is directly 10.0.2.2 network is directly connected with its own interface. That time it will again change the MAC. Source MAC will be MAC E and destination MAC will be MAC F. Okay, likewise when destination MAC is MAC F, then the traffic is moved towards this switch, and when it moves towards this switch from the MAC table, it will get to know the destination MAC is MAC H. That time the source MAC will be MAC F and destination MAC will be MAC H, and the traffic will be received into this computer. So in the headers, IP source and destination doesn't changes. IP source and destination will be same, but the source MAC and destination MAC will be changed by per hop. When the traffic is here, the source MAC will be MAC B and destination MAC will be the MAC C, which is the gateway interface for this device. After reaching it to the gateway, it will search into the routing table. It will find that the outgoing interface is 10.0.0.1. So it will change the source MAC towards MAC C, and the destination MAC will be that time become MAC D, which is the MAC address of this point-to-point interface. After travel this, after getting this, it will travel here in this router, and that time it will change again the source MAC towards MAC E and check the routing table, and it will find this is a directly connected interface, and the destination MAC will be MAC F. When it's the packet is received by this switch, that time it will change the source MAC to MAC F and destination MAC will be MAC H. Likewise, the packet will be traveled. So do you understand what is preamble? Preamble is nothing but the lots of data are, means we are receiving and transmit day by day a lot of data from one device to another device. Who will segregate the device data? Means it can be overlapped, right? It can be mixed up. So preamble is the field which is taking care of these things, who cannot mix up the data. Like you can it differentiates the data. This data is for this traffic, this data is for this traffic, like what preamble does. And it consists of 7 bits, and 1 bit is there for SFD, which is start frame delimiter. It defines from where the data will be starting. You just write hello, HELLOW. So when it's received by the other device, the destination device, so it should be hello. It's not like OELLHO, not like this, right? The same traffic will be received by that end. So those things are defined by SFD, start frame delimiter, from where the data will be started. This is preamble. What is destination MAC and source MAC? I have already discussed. Type. Now coming to the type field. Type means what type of information is encapsulated with this header. Is it an IP header or is it an ARP header? That is called as type field. After the data field means the actual data which consists inside that frame or the traffic. After that it will come FCS. What is FCS? FCS is nothing but whenever router or a device send a data from a source towards a destination, that time itself it generates its CRC. CRC means cyclic redundancy check. Once it calculates its CRC, it includes that CRC value into this FCS field, and it moves the packet towards the destination. When the destination when the frame received by the destination device, again it calculates its FCS, means CRC, cyclic redundancy check. If the CRC is matched from the source end towards the destination, then only the data traffic will be received. Otherwise, it will be not received. And it is used for the error detection part. So these are the properties in Ethernet header. After that, IP header got starts. Okay. Hello.
Yes, we hear. We hear.
Do you have any doubt in this Ethernet header?
Oh no, it's okay for now.
You understood?
Yes, pretty much.
Give me 1-2 days. I'm having some issues because I don't have the pen board. That's why. If I'm having the pen board, I can draw the diagrams and make you more explainable this thing. Just whatever I told, these things keep in mind. This is the first class, basic class. So type in the type field, how the traffic will be. The traffic will be can be any type above L2. Means L2 means the data link layer. Above data link layer, any traffic can be calculated inside this type field. So what can be the type of the fields? One is IP header, one is ARP header. So I am going to show you how to check the IP and ARP header. Okay, just watch this carefully. The practical.
Yeah. Click on file. Click on file. Create new blank.
No, it's not yet connected to the local server. That's why.
Yeah.
United one. So I'm taking two routers, R1 and R2. You can see it here. I will show you the ARP packets. We'll capture the pack links and we'll show you through Wireshark. See, I will not configure anything. Interface. So before that, I will start capture the packets.
Don't you have to send any ping before start capturing the packet?
Yes, I will do it. I will do it.
No, I'm just asking.
See here. I will ping. Dot 0.0.1. If I ping, see, first packet will not go. First packet will not go after the. Why this packet was lost? So that thing I'm going to show you in this. See, first I'm sending the packets. If I open the packet, Internet Protocol version 4. See, type field.
Stop the capturing, boss. Now you can stop the capturing, right?
Just showing the ARP request and the.
Here is ARP request. Scroll up. Scroll up. Before first ICMP traffic. Before first ICMP traffic. In the bottom. This one is Gracious ARP.
This one, right?
Just lower one, the broadcast packet. Yes, this one. Click on it. This one is Gracious ARP.
Type field I am searching for.
Okay.
Bytes captured ID, Ethernet, SRC.
So in Gracious ARP also you will find type field.
Type ARP, you can see it here.
Yeah.
It generates ARP fast. That's why the packet got dropped, because it was searching for its destination MAC address. That's why the router interface generated ARP, and it's got reply from. It's generated ARP from this interface. ARP